Here we're tackling the problem trapping rainwater. Our goal is to try and solve this with minimum complexities of on time and o1 space. So, in our problem statement, we're given an array of n non-negative integers representing an elevation map. The width of each bar is 1, and we need to compute how much water can be trapped between the bars after raining. I thought this would be slightly easier with visual representation. So we're given an elevation map represented by an array of non-negative integers. As you can see, our elevation map represents the height of the bars, and the width of each of these bars is 1 exactly. Looking at each of them. Now, we need to calculate the total amount of water that can be trapped between the bars after raining. And as you can see in this case, we've got an elevation map with this array, and eventually 6 units of water that can be trapped here. I would recommend reading the problem statement on LeetCode thoroughly before you attempt this problem. In any case, you have 4 possible methods that can yield a good solution here. They are A, 2 pointers, B, dynamic programming, C, greedy approach, or D, stack. I'm going to pause for a couple of seconds while you make your choice. So, for those of you who recognize the most optimal among these, congratulations. And for those of you who just want to see the code, the answer here is A, 2 pointers. The brute force approach to this problem is accessed by looking at the hint button. Now, we would iterate over every bar in the array, calculate the amount of water trapped between each bar and its adjacent bars, and then simply add them. However, this would have an approach of on squared, which is part of the reason this is a hard LeetCode problem. This would TLE in LeetCode's I think it would TLE in LeetCode itself if we tried it. Now, in our optimized solution, we use a slightly different approach using 2 pointers. So, in this, we use the technique to compute the amount of trapped water more efficiently. We maintain 2 pointers, one of which starts from the left and one of which starts from the right. Now, just give me a moment. Essentially, throughout this rather lengthy solution, we gradually move the pointers towards one another, keeping track of the maximum heights encountered on the left and right sides. And we make a calculation for all of the trapped water. I think that this makes better sense if I go through it line by line. So let's take a look at that to start with. So we start with the sz variable, which stores the size of our input array height. After that, we find the index of the maximum height in the array by iterating from 1 to sz minus 1. Of course, we initialize max index to 0 and then check it against every other element in the array starting from index 1. If we find a greater height, we simply update max index to that index. After we've done that, we initialize the variables max left, max right, and answer. Max left and max right will keep track of the maximum height encountered on the left and right sides, respectively. Answer is initialized to store the total amount of trapped water. After that, you can see that we have 2 more loops. So, looking at the first loop, we iterate from index 0 to max index minus 1, updating max left by taking the maximum of the current height and the previous max left. We then add the difference between max left and the current height to our answer. So, I hope that that's clear. You can see what's going on here. In the second loop, we iterate from size minus 1 to max index, to max index plus 1, excuse me, and we update max right by taking the maximum of the current height and the previous max right, like so. We then add the difference between max right and height, the current height, to answer. After we've done that, we simply return the total trapped water which is stored in answer. And I hope that if you try this, debugging and looking at one of the test case examples to help you, you'll understand exactly why this code works so well. In any case, that's one problem-solving session or method explained using Coding Card Shop, where we've used one of these 4 methods to try and solve trapping rainwater. This is one of the harder problems in the early section of the Coding Interviews course, and I would strongly recommend checking out the Udemy video if you're really struggling. So, of these methods, you will be using the 2 pointers approach, and you can use this to help you understand the answer. If you're someone who prefers to use code, you can look at it in C++, Python, or Java. And as always, I will point you in the direction of the Udemy course, where there's a far superior explanation available, as given by Dr. Mustafa Ibrahim, who is an experienced competitive programmer and a real expert in computer science generally. Anyway, for the purposes of our application, we're done, and the next one in this series will be build array from permutation, another slightly tricky problem. Thank you for watching, and I hope we'll see you in the next video.